Okay, you guys, so your question of the day today was the normal boiling point of ethanol is 78.3 degrees Celsius, and its molar enthalpy of vaporization is 38.56 kilojoules per mole. What is the change in entropy? I'm going to underline that. That's what we're looking for. Delta S. In the system where 68.3 grams of the ethanol at 1 atmosphere condenses to liquid at the normal boiling point. So there are two ways to calculate delta S. We can do the products minus the reactants. And this is for like a reaction. And so here I'm seeing that we're talking about condensing, which is a phase change. So for a phase change, we know the temperature doesn't change while the phase changes. So this is an isothermal system, which means that we can use the Q over T equation. So Q and T. So we said that this is happening at 78.3 degrees Celsius. 78.3 degrees Celsius. Of course, though, we've got to get it to Kelvin. So 78.3 plus 273, that should be 351.3 Kelvin. And then our Q value, we're given the enthalpy of vaporization. Remember, in a constant pressure volume system, Q equals the delta H, which is 38.56 kilojoules per mole. Now, the question is, do we have a mole of methanol? I don't know. We have 68.3 grams. So let's go ahead and just figure out how many moles that is. So I'm going to go up to the top here. 68.3 grams. And if I want to get grams to moles, I need to use the molar maths. So 2 carbons. Each carbon is 12. So 12 times 2 is 24. And then I've got 6 hydrogen. So I've got 1.008 times 6, 6.048. And I have 1 oxygen, which is going to be 16. I've got 8, 4, 0, 12, 13, 14, 15, 16. So 46.048. So I've got 46.048 grams for every 1 mole. So 68.3 divided by 46.048. I have 1.48 moles. So not just 1. So I'm going to take that Q value times 1.48 moles. That gets my moles out of there, and now I'm just in kilojoules, which is what I want. So I am going to take, times 38.56. So my Q is going to be 57.19 kilojoules. Oops. Sorry. And I'm going to divide by my temperature of 351.3 K. That gives me, I multiplied instead of divided. 57.19 divided by 351.3. You guys, my math here, 351.19 divided by 351.3 equals 0.163 63 kilojoules per K. And then I have this question down here, you guys, of should it be positive or negative? So let's see. So is my entropy increasing or decreasing is the question. So I'm condensing, which means I'm going from a gas to a liquid, which means that this should be a negative value because I'm losing energy when that happens. I'm going from that crazy gas to that flowing liquid. So this is going to be my change in entropy. So you guys have a couple of things to do today. We didn't quite get those notes finished, so you're going to watch the rest of the notes video. It's linked in the agenda. And then you're going to finish the worksheet that we got on Friday. The answer key is linked in the question of the day. It's also on Moodle. And then there's one more entropy practice packet. It's got some multiple choice questions, so you can get a look at the type of questions I might ask on the test, and then some calculations. And we will go over that first thing on Tuesday. So remember, our test is Wednesday. You've got the review sheet. Start working on that. I'm going to give you kind of a sneak peek of tomorrow. We'll go over questions with the entropy practice packet, and then it's going to be review time. If you want to retake the Chapter 5 quiz, Tuesday is the day to do it. Send me an email. Let me know that you want to, and I'll have one ready for you. And then just know you're going to have a little bit more reviewing at home. But those answers and videos are posted on Moodle. So you have all the resources you need at this point to get ready for that test. So I will see you guys tomorrow. Have a good day. Email with questions. I won't answer during the day, but I'll probably check it at night.